Let's focus on some key BC Math 10 concepts. We have some formulas here, the slope formula, the slope point formula, we have the arithmetic sequence formula, and the formula for the perpendicular slope here. Find the prime factorization of 1575. Let's begin by pulling out the 5. And the question is, what's 5 in terms of it fitting into 1575? In other words, what's 1575 divided by 5? Let's just use some long division. 5 times 3 is 15. We carry down the 7. 5 times 1 is 5. Subtract. Pull down the 5 here. And 5 times 5 is 25. And there's no remainder. So we can see that we're making progress here, and we can pull out another 5. What's 315 divided by 5? 5 times 5 is 25, so 5 times 6 is 30. We subtract, we have a 1 and a 5 here. So 5 times 3 is 15, and there's no remainder, so we have 63. What times what is 63? We have 9 times 7. And the 9 breaks down to 3 times 3. So you can see that we have the prime factorization is 3, 3, 5, 5, and 7. We can also write this as 3 squared times 5 squared times 7. Now, what are the factors of the number 15? Now, think of the numbers 1 and itself. Yes, they are factors. But when we break this number down, what else fits into 15? We have 3 and 5 as well. 3 fits into 15, and so does 5. 5 fits into 15 as well. Next, let's find the Gcf and Lcm of 15 and 25. We have 15 and 25 here, and it's good to draw this L. And let's focus on the Gcf first. What fits into 15 and 25? Let's try 5. 5 times what is 15? 5 times 3 is 15. 5 times what is 25? 5 times 5 is 25. So as you can see, there's nothing else to do because these are both prime numbers. So we circle the left, and that's your Gcf. Now to find the LCM, you just multiply all these numbers. What's 5 times 3 times 5? 5 times 3 is 15. 15 times 5 is 75. 5 times 5 is 25. 25 times 3, it's probably easier, is 75. Let's try a few more questions. What is x cubed times x to the 5? When the bases are the same, we add the exponents. So what's 3 plus 5? It's 8. When we have the same bases, but we're using division, we subtract the exponents. So we have x to the 10 minus the bottom exponent, which is negative 3. Now be careful because 2 negatives make a positive. So we have x to the 10 plus 3, which is x to the 13. Now what about negative exponents? When we have a negative exponent, we write it as 1 over the base to the positive version of the exponent. What is 5 cubed? It's 5 times 5 times 5, which is 125. And when we have a fraction to the negative exponent, I recommend that you flip the fraction. We have 3 over 2 to the positive version of this negative exponent, which is 2. And now we use exponent rules. We spread the love to the top and to the bottom. We square the top, 3 squared over 2 squared, which is 9 over 4. Next, we divide. And when we divide by a fraction, that's the same thing as multiplying by the reciprocal. We flip it. Without thinking too hard, we just simply move the bottom, the denominator, to the numerator, and we move the numerator to the denominator. So now we can simplify. We have 4x squared times, or dot, x cubed over 2x. So this is the same thing as saying x squared over 2. We can cancel out an x from the top and bottom. We can also think of this as 4x squared over 1, and we can simply multiply across. So 4x squared times x squared is 4x to the 4, and 1 times 2 is 2. 4 divided by 2 is 2, so we have 2x4. I'm going to try this question one more time. So when we were here, let me just draw a little arrow here. We could simply rewrite this as 4x squared over 1 and multiply across. So we have 4x squared times x cubed all over, multiplying across. 1 times 2x is 2x. And you can see we can start simplifying. What's 4x squared times x cubed? We have 4x to the 5. I'm adding the exponents. All divided by 2x. There's a hidden 1 here. 4 divided by 2 is 2. X to the 5 divided by x to the 1 becomes x to the 4, because we subtract 5 minus 1 is 4, and we have the same answer as before.